That's us. We are live.
Right on. We did it.
We did it.
We did one thing.
Sometimes you have to call that good enough.
Okay, you heard it, everyone. Today, that's it. That's all we're doing. We got the episode live, and now we're just going to wrap it up because we've really accomplished everything we needed to do today.
So the frustration I now have is I know somewhere on Google Drive there is a list of all the Patreon people that I'm supposed to say at the end of the episode. I have
Now,
no
do you want me
idea.
to be a little smaller? Do you want to make me smaller?
Yes, I can do that actually. That is in my ability.
Sure. I can do that too, but
Yeah, now let me do that on this end. Oh, guys,
okay.
guys. I've been in telecons or recording long enough that my dogs are just like, Mom, 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 Mom.
Yeah. You've exhausted their patience.
I have. So can you move the top of your head closer to the top of your, come on up, pick a direction. Can you adjust the top of your head closer? There, that direction. I see you. I don't know what
Let me
you
look
want.
I'll look at what it looks like, and then I'll sort it out.
Okay.
That looks okay.
Yeah.
The only problem is, yeah, okay. I'm actually hovering above my background, but no problem. Pay no attention to my lack of torso here.
I hadn't noticed that. That is a thing.
Yeah, I'm just a floating head, floating portrait.
Let me see if I can put a black box there, maybe, or can you
No,
put
I
a
can,
black box?
it doesn't matter.
Yes,
Oh my
that
God.
one does.
It doesn't matter.
You're having way too much fun with this.
There.
I love you too. This is a lot.
I mean, what I could do is shift my my camera down, but my camera's tripod is locked in pretty hard, and it would be dangerous.
I understand
So
that.
that's why I'm not going to do that. Man, today's a big day actually.
Really?
So on our new shop, they poured the concrete pad today.
It got dry enough finally?
Today was the only sunny day we've had in all of November.
Oh
and
my
so
goodness.
yeah, so the sun is actually shining. It's beautiful.
Oh
And
wow.
yeah, and it's warm, really warm, and so it's going to be perfect for the concrete. So we had it's crazy. Like our regular builders, they do everything else, but they just get out of the way and they bring in a special team of people just to do the concrete. And so we had
They
maybe
don't want
10
that on their
people.
conscience.
Yeah, no, it's really tricky business.
Yeah.
And
yeah.
so there's like maybe 10 people showed up for 2 hours to pour all the concrete. And then one person or two people remaining to do the final, it's called a power trowel, but essentially the big spinny fan that they move around on top of the concrete to smooth it all out.
Oh jeez.
So yeah, but it's been it's been good. So hopefully that's another big issue out of the way, and now they can frame up the building and we can get a roof on probably in the next 2 weeks.
That's starting to get super exciting. Do you have any idea of just like what there's always a target move-in date and it is always full of lies.
Yeah. I mean, it's probably February is when we'll be able to. So we're gonna have to suffer the entire winter in the trailer before we're actually able to move into the studio.
So what I'm finding is my dogs are willing to all come hang out with me in my little tiny home office. And when you get basically 500 pounds of mammals between me, tiny intern, and 3 dogs, that room gets warm. So you're going to be saving on heating, and maybe you want to get that dachshund to eat the mice that I keep mentioning.
Right. Right. Need that dachshund.
I'm very
Um,
much team Fraser needs a dachshund.
yeah. Yeah. Um, what else did we do? We found a dead owl. That was weird. Oh,
That's disturbing.
and we had a cougar get picked
Which
up on
is
one of our cameras.
that is awesome. Do you have coyotes there? I don't know where
No, we don't have
coyotes
coyotes
go.
on the island. They have them on the mainland. We don't have them on the island.
Okay.
We only have bears and, yeah, and big kitties.
Do you have moose?
We don't have moose. No, we have elk.
Okay. Those are still horrifyingly large creatures.
Yeah, they are quite large. All right, are you ready?
I'm still looking for that file link to where all of the patrons are listed.
Oh, okay. Then I don't want to distract you. Find that.
Well,
file
I'm
link.
just scrolling backwards through different chats trying to figure out where it got put. Like, I think it must have been somewhere other than Discord. I may have to go back and add those later.
Okay. You want to do that?
Yeah. I'm just
Okay.
sad. I'm just sad. I'm gonna check one
Yeah.
more conversation.
That sounds. I mean, it could be anywhere.
I know, and
Yeah.
the issue is it's not one that was shared with me. It's one where the permissions were made,
Mhm.
so that I can see it, which is not the same thing. So I can't just search for it on Google Drive.
Yep.
Okay, I'm gonna look in one more place.
Yeah.
One more place.
John Stuffield wants us to get on with the podcast. John, you're watching you get to tag along and watch the sausage get
Yeah.
made here. This is not a show to entertain you. This is you getting a chance to hang with us while we do this.
Yeah,
If you want,
this is the
like,
live
just listen to the
studio
podcast.
recording.
That's the finely edited final version.
Yeah, this is
Yeah.
where you get to find out all the times where like Fraser asks me things. I have no clue what the answer is.
Yeah.
Yeah.
But yeah, so that's I mean, like I don't do my I do my live QAs every Monday, but I don't make the video available after the fact. Like I just hide them afterwards. And
Oh yeah, and then we post an edited YouTube video of Astronomy Cast as well.
Yeah, exactly. Yeah. And so that's the I think that's the compromise, which is like if you want the live show, then this is the live show.
And the thing, like we got a complaint, which I understand, that we now have ads in Astronomy Cast. And I'm just trying to pay all the bills, humans. I'm just trying to pay all the bills. And it's we do things in stages. We make things available to you as soon as we can. We try and do things. We do an unamazingly large number of things given how small groups of humans at Universe Today and CosmoQuest are. Across everything Fraser produces and everything we're producing, I don't know how we do it. And I'm sorry that we have to have ads.
Working out of the back of a trailer that save on costs. That's the key.
Hey, I'm working out of a basement where chunks of ceiling periodically fall.
Yeah, exactly. Yeah, it's funny, the 22 years now of running Universe Today, I think my office has degraded. I started at the kitchen table of my apartment and then moved to my own separate little nook inside my house, and now I'm back down to the mouse infested rain smattering metal trailer that I'm living in.
What is today's episode number?
620.
Okay, I got it right.
Yay.
Small gifts. Okay, so are we ready to attempt to do this thing?
I'm ready.
All right. I'm I'm pressing record. I'm
I'm
pressing
pressing
the
record
other
too.
record.
And did it
Everything
work?
is recording.
Wow. First time. That's a time saver. All right. Astronomy Cast, episode 620. Why getting to the outer worlds is difficult. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well, Fraser. It is one of those picture perfect fall days where the wind is howling, the leaves are blowing, and you can just tell that snow is coming at some point.
This is the first sunny day that we've had in all of November, and probably for like the last 2 weeks into October as well. It has been a wet fall. So yeah, it's kind of nice to be able to stand outside and feel the burning orb of the sun on your face.
Well, you
Um,
do live in a tropical rainforest.
temperate.
Temperate rainforest. You
Yeah.
live in a temperate
Yeah.
rainforest.
Apparently that I guess comes with a lot of rain.
It does.
Yeah, it's right there on the packaging. No, true that. No snow yet, but it's close. We see the snow line inching down day after day, and so it's just a matter of time before the snow gets to us.
Yeah, it's five hours drive north of us right now, but I live where it's flat, so it's not like you can gain anything by going up a hill.
Right. All right, good news. Over the next few years, we're going to see a flotilla of new missions headed to Jupiter and Saturn. Why aren't we seeing more missions to the outer planets like Uranus and Neptune, even Pluto? It turns out those places are far away. Today, let's talk about the challenges of exploring the outer solar system. And we'll talk about that in a second, but first a break.
And I'm gonna get rid of the dog.
And we're back.
Wait, I have to get rid of the dog.
I know.
Hold on.
Absolutely get rid of a dog. Richard can edit this out.
Come on. You are good. How? You, come on. Go away.
You did this yourself, Pamela. And you want me to get a Dachshund. You want me to get an additional dog. I know better.
She can open doors now.
Yeah. Like, you're recommending me get another dog? Come on. 2 dogs is too many. 2 dogs is like 5 dogs. 3 dogs is like 40 dogs. They go up exponentially.
I hear no lies.
Yeah. All right. Right. So it's, I think like one of the things that we've talked about for a long time is how sad it is that there aren't any missions planned for Uranus, Neptune, Pluto, the Oort cloud. It sucks. Why?
Yeah. So there's two different problems. And which one you worry about more depends on the science you're trying to do. The first problem is just getting out there fast enough so that you can accomplish your science within a human lifetime. Or at least with the next generation, we do build missions where we know that it's going to be the next generation of scientists who do the science.
Yeah.
So getting there fast enough is problem one. And then problem two is if you want to do more than a very brief flyby, you have to figure out how to drop all that velocity that you've gained, all that momentum that you've gained, and somehow get yourself in orbit around one of these worlds so that you can do lasting data collection.
All right. So, and I think that's going to be a bit of a surprise to people. So let's tackle that first.
Okay.
So you've got this idea, I guess. You'd say you're going to a mission to Pluto.
Yes.
And you want to do a flyby. Actually, you know what? Instead of Pluto, let's do this again. Let's say you're going to want to launch a mission to Mars.
Okay.
And you've got kind of two options for how you do this mission to Mars. One option is that you can do a flyby. And so you just take some pictures, you don't get caught in Mars's gravitational field, and you just fly on through. The other option is that you attempt to go into orbit around Mars. So how does that change between those two mission parameters? How does that change what kind of a flight, what kind of a mission timeline are you looking at?
Well, in the getting there part, it doesn't necessarily have to change anything. And we have this fabulous example where with Curiosity, we had the two Mars CanSats essentially that flew alongside.
Oh, with
When
Perseverance, right.
it was with Perseverance. Okay. So with Perseverance, we have this excellent example of these two little CanSats that flew along with the mission that went to Mars. And then they did that flyby and kept on going to explore the outer solar system. Not that they're really returning signal anymore. But the difference between these two different missions was the CanSats really didn't have the fuel, the maneuvering ability, or anything that would allow them to dump velocity to go from orbiting the sun to instead orbiting Mars. Perseverance
Right.
instead was able to brake using a whole bunch of different techniques from, well, very carefully maneuvering so it could just graze the atmosphere and aerobrake down through, well, of course, it had parachutes and retro rockets that all together allowed it to land safely.
And so you've got this situation where you're blasting off at high speed to you're following this perfect trajectory out to Mars that uses the minimum amount of propellant to arrive there. But as you say, in the case of Perseverance, it had a parachute, back shell, landing crane, aerodynamics to be able to actually sit down softly on the surface of Mars, while those CanSats, they're just little bricks that
Yeah,
flew right past. They had no way to go into orbit, and so they had no way to stop. And so
right.
if you wanted to have those things go into orbit around Mars and do a longer mission, they would had to have had like booster rockets all on their own.
And they did not. And
Right.
and it with Mars, at least you have the ability to utilize not just its gravity as something that can grab onto you, because that's always going to be there to help. But that alone is not enough. It was that atmosphere that really made the ultimate difference and allows them to slow down these missions without having to use a whole lot of energy.
And so the implication then is you can either have retro rocket or science payload.
Yeah,
And so in the case of the Mars CubeSats, they chose payload and no rocket
right.
and or landing system. But the landing system is heavy, and you've got to make that it's that trade-off every time.
And when you choose both, I mean, so it's really that classic pick two of three. It's you either have to make it affordable, you have to make it so that you optimize for science, or you have to make it that you optimize for getting yourself onto the surface.
Right.
If you get rid of the optimizing for cost, that leaves you room for both science and those engines that slow you down and put you in the correct orbit, or in this case, even allow you to just plain land.
So
Pick
so let's
two.
Lennox, let's extend this idea now to missions to the outer solar system. So say you want to go to Jupiter, Saturn. Um, I think a good example of one that was actually proposed fairly recently was or actually a mission. Let me do this again here. So let's look at something in the outer solar system. Then let's look at say the New Horizons mission to Pluto, which we know took about 10 years.
Yeah.
And what kind of a flight plan did that mission take?
Go fast, 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 fast. Fast. Go
Right.
fast.
Faster. Yeah.
It was amazing. They took this little teeny tiny spacecraft, as far as spacecraft can be considered. They took this itty bitty little tiny spacecraft, put it on top of the biggest rocket they could reasonably get, and just launched straight escape from the planet Earth. No once around. They didn't bother with any of that. They just went from ground toward Pluto. Now, they did have some encounters along the way. This allowed them to test their instruments. They did get some gravitational boosts. But that wasn't the focus of their orbital route. The focus of their route was, we're not going to do a Helmholtz orbit that has the Earth and Pluto in this nice, easy, low energy transfer between the two. No, we are simply going to do an escape velocity from the sun heading straight out. It
Right.
was kind of awesome.
And at times, New Horizons was the fastest, or I think had some of the fastest velocity going through the solar system. It's since slowed down now because it's essentially climbing out of the sun's gravity well, and the Voyagers are faster. But for a while there, it was a very fast spacecraft. I think now, like the Parker Solar Probe has taken the record for the fastest spacecraft that humanity's ever launched. But so that, again, back to this idea, you've got this mission flying like a bullet, picking up more velocity thanks to Jupiter. There's just no way to slow it down. It's going to hurtle past Pluto at high speed. So what if mission planners had said, we want New Horizons to be able to go into orbit around Pluto? How would that have changed the dynamics of the mission?
It wouldn't have changed just the dynamics. It would have also changed like how rugged the mission had to be. Imagine being on a set of roller skates with a safety harness on that is attached with a solid steel cable to a pole.
Mm-hmm.
And you fire those like water jets that people now use out over the ocean to go as fast as you can in a straight line. And then you hit the end of your cable and you suddenly get jutted sideways. That sudden change is not going to be comfortable.
Yeah.
And what you're looking at is, you either do the go, 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 stop as hard as you can and hang a sharp corner as you put yourself into orbit, or you have to plan for a substantially longer period of time to get there, where you don't get to as high a speed, or you start decelerating much earlier,
Right.
so that it's a gradual process that allows you to more casually enter orbit around Pluto.
All right, we're going to explore this some more in a second, but it's time for a break. And we're back. Now, I worked on an article a few years ago about this idea of Hohmann transfers, where, and this is what you were talking about earlier on, that you sort of follow this perfect trajectory. I'm sure we've all seen this animation many times, that you've got this trajectory where your spacecraft leaves the Earth, it's on this larger ellipse, and it just happens to end up exactly where Mars is crossing, and boom, you've got the least amount of energy and the easiest deceleration on the other side. So if you didn't do that straight shot to Pluto, if you want to do a Hohmann transfer to Pluto, you're looking at about 46 years of flight time to be able to do that. Plus, you need a deceleration system. So no one's got time for that.
I did not start learning orbital mechanics as toddlers. So, like, that mission would have had to have been started by a prior generation for us to have any hope of working with the data.
And so you've got this enormous, just immense flight time, this 45 years. That's way too long, obviously. And so the way you cut that time down is you put a rocket on your spacecraft that can decelerate and start to knock years off of that time. It speeds up, and then it turns around and slows down, kind of like in The Expanse or other
it's
TV shows that we've seen.
Classic, your spacecraft flips over, points its engines in the other direction. It was on Foundation, I think, last week or 2 weeks ago. It works. This is why science fiction authors use it.
But the challenge then is you have to give up science instruments for this, this material, for
Yeah.
your propellant, for your engines, etc. So let's talk about some missions then that were on the books that have since been kind of canceled, pushed back. I think the most famous example fairly recently was the Trident
Triton.
mission.
Yeah.
Yeah,
That was actually a flyby mission.
of
And
course,
of
because
course,
no one's got time for an orbiter. Yeah.
I I I keep hoping. I keep hoping. So Triton was a mission to the moon Titan that is a captured Kuiper Belt object bigger than Pluto. And we know it's captured because it is going the wrong way around its world, which is Neptune. And the way its surface is modeled is consistent with the release of energy that would occur while going from a highly elliptical capture orbit down to the circularish orbit it's in today. And
Yeah.
it would have been awesome.
Right. And unfortunately, it was not selected while missions to Venus were. I think we've gone on quite a bit about this.
But it
Um,
can be resubmitted. I mean,
but of
it's
course,
not
yeah,
dead, it's
yeah.
just not happening right now.
We've got the Titan Dragonfly, which is
Yes.
leaving for Saturn later on this decade, but it's gonna probably take, I think, like 8 years. Like, it's gonna take a long time to
Yeah.
get out to Saturn, and Saturn is incredibly close compared to Uranus, Neptune, and Pluto.
And so they're taking care not to put too much velocity onto the mission getting out there, which is a cost savings and energy savings. It going slow is easy. And then the other thing that Saturn and Jupiter both have going for them is they're much more massive.
Hmm.
And that additional mass allows them to just put that extra pull onto the spacecraft to, well, keep it.
And of course, with the Dragonfly mission, once again, you've got an atmosphere that you can use.
Right.
The Titan atmosphere is way thicker than Mars. It's a piece of cake,
Yeah.
relatively speaking, to aerobrake into the Titan atmosphere. And so if you didn't have that atmosphere of Titan to be able to absorb that energy as your spacecraft was flying at it, Cassini had a much trickier job to be able to go into orbit around. That was a full 10 years, I think, to actually get out to Saturn. While, like, when you go back to, say, the Voyager missions, the Voyagers launched in 77, they hit Jupiter in 80,
Yeah.
Saturn in 81.
And they
It
just
only
went
took
full tilt boogie the
full tilt, yeah,
entire time.
flyby, yeah, exactly. And so you're gonna see these places that actually have an atmosphere are going to be the first places you're going to get landers, possibly orbiters. There's this cool idea of aerobraking that's been
Yeah.
done.
And there's also the potential, but they have complicated magnetic fields that you have to watch out for. There's still the potential to break your spacecraft not apart, but slow it down, break it in the atmospheres of Saturn, Jupiter, Neptune, Uranus. And so these gas giants give us an opportunity we don't have with rocky things like Pluto, or at least icy things like Pluto, Triton, the other Kuiper Belt objects,
Yeah, you would be lithobraking into those objects.
which is both forms of breaking.
Yeah, exactly. All right. Well, I want to get into some solutions in a second here. But first it's time for another break. And we're back. All right, so let's talk solutions. We've been talking about problems. We're talking about how our expectations for a fully explored outer solar system have been delayed, and we're sad. So, what are some ideas? We pitched a couple already. This idea of using atmospheres to, I guess, remove the need for bringing a rocket. What else can be done to try to lower those flight times to the outer solar system?
Well, I mean, ultimately, you want to have the planets in perfect positions to allow you to get just the right set of gravitational assists to speed you up and slow you down.
Hmm.
We're not going to get the planets in the right places do that for a long time.
Right.
So that's not useful for any of the next several generations of astronomers. But it's a possibility. It
That's
is a
an
possibility.
that's an interesting idea. So you could say fly out, you could launch from Earth, do a gravitational slingshot around Jupiter to speed you up, and then do a gravitational slingshot around Saturn, but go the other way to slow you back down, and then you would have an easier time of being able to slow yourself down when you actually got to Uranus or Neptune.
And I'm not sure it would work that simply, but
Right.
it allows you to do something like take off from the Earth heading inwards, get your acceleration off of Venus,
Hmm.
and then on the outside, slow yourself down. And it gets tricky orbital mechanics. It's not a straightforward problem. But these are the types of creative solutions you can start to look for. And beyond that, it's just a matter of figuring out what is the correct way to combine technologies.
Right. So let's talk about some advanced propulsion systems that could fill that gap.
Well, so while we generally think of ion drives as being the slow solution to things, there's that potential that you zip yourself out with a rocket, turn on that ion drive when you need to, and very slowly slow yourself down. And this gives you a low mass solution that will do what you need. And it's a compromise. It's not the perfect solution, but it's a compromise.
Yeah, I mean, we've seen ion engines capable of boosting spacecraft to
Oh, yeah.
vastly higher speeds than than any a chemical rocket could ever do, just because they are so efficient with their propellant.
They just do
And
it over
right,
years.
and if your flight time, if your cruise time is going to be years anyway, maybe you could accelerate up fast, turn around, slow yourself down.
Well, you don't
I
even,
think
if you build it right, you don't even have to turn it around. You have your jet propulsion sets you up on the accelerating, and then your ion drive sets you up on the slowing down.
right, yeah. And then I think the other opportunity that's coming up is a new class of launchers like say Starship.
And this is where it's a matter of, and now we don't really care about how much mass we use. We just take
So
all
the
of it. Take
yeah,
all of
exactly.
it.
Yeah. Yeah, it's hard to wrap your head around how much fuel Starship could theoretically carry on board when you if you filled it, like if you launched Starship, refueled it to capacity, and then set off for the outer solar system, you could just full burn, turn
The
around, full burn, and you could knock years and years off the flight times
the
with a rocket that big.
the thing that got me about Starship was someone pointed out the other day it could have taken up the entire International Space Station in 3 launches.
Yeah.
And
Yeah.
it's just sort of like, you just defined my
Yeah.
entire teenage through adulthood transition to being the adultier adult was defined by the construction of the International Space Station, and you've reduced it to 3 missions. And it's
Yeah.
just,
And it could be the same rocket, and it could do it in one day, right?
I don't think they're going to get 3 launches per day out of the same Starship,
A
but
Starship in theory will be able to fly 3 times in a day, and a Super Heavy will be able to launch 8 times in a day. So in theory, this one Starship could launch the entire International Space Station in one day. I agree, that seems unlikely,
yeah.
but on paper, that's the plan. But,
Yeah, I just look
we'll
at it
see.
like, sure, you could also fly a 747 back and
Yeah.
forth from Boston to London 3 times a day, but they're
Yeah.
probably not going to use the same 747.
So what
Cleaning
about
time,
going
people. Cleaning time.
and so there are some other interesting propulsion systems that have been proposed to go vastly farther out into the solar system, places like out into the even out into the Oort cloud, ideally. So I don't know if you've seen this, is the idea of a an electromagnetic sail. So
No.
you have this, it looks kind of like a wire net in a big circle, and you electrify the wire with solar power, And then what it does is it then interacts. You make it positive, I think, and then it interacts with the negative ions coming from the sun's solar wind, and they give this thing a kick.
Uh-huh.
And NASA awarded a NIAC grant to one of these proposals a couple of years ago. And the thinking is you could reach deep areas into the outer solar system, essentially to wherever the solar wind starts to really tail off, which is like out at the heliopause. And you
Dang.
could do it within, again, just a matter of years. The acceleration is tremendous, but then it's really hard to turn it back off again because you've got all that speed. So you're back to flybys, right?
Right. But
Yeah.
you can get there fast. You just
Yeah.
so one of the ideas that it's an imperfect solution, but I really like it, is we've seen in a variety of science fiction books. Kim Stanley Robinson has put this forward. The folks behind The Expanse have put this forward. The idea that you have a variety of transport vessels, asteroids that are hollowed out, whatever you wish, that are systematically entering this transfer orbit such that they sync up and you can jump from one means of getting outward to the other relatively simple. So you take a transfer orbit that gets you to a transfer orbit that gets you to a transfer orbit,
Right.
and you essentially have these set up as stations. And I mean, imagine the day where you can essentially spend your life working on your PhD while building the instrument on the way out.
Right. Yeah. So you really come along for the ride.
Yeah.
The other idea that we've been reporting on is this idea of taking an RTG, a nuclear RTG, like what Perseverance or Curiosity has on board, but just like the raw heat producing RTG, electricity producing RTG, bolting it to an ion engine, and then having a very small payload that goes along with it. And so now you've got a spacecraft that is capable of kind of ludicrous amounts of change in delta V. So like
Yeah.
40 kilometers per second change of delta V, 100 kilometers per second of delta V. One proposal for this is to go and chase down Oumuamua, grab a
Yes.
sample, and return back to Earth with it.
Yeah.
So I think when you think about traditional chemical rockets, you've got to be thinking in decades, but we're now at the point there are enough really fascinating new technologies that are coming online, either just massive rockets like Starship or
Which is
these
still
advanced
chemical.
or these advanced technologies like ion engines, RTGs. There's also nuclear rockets, and even
Right.
there's a fusion rocket proposal that NASA is working on as well. So I think we're going to see this drought of outer solar system exploration start to wrap up in the next couple of decades. I mean, that still sounds like a long time, but
So
the
the
drought is
science
almost
fiction
over.
story I now want to find someone to write is that future where the graduate student in a 3D printer gets to work on flying their way out to the outer solar system through this series of Helmholtz transfer orbits,
Yeah,
and they have to complete their instruments before they get there and start their return.
very cool. Let me know when you finish writing it.
Oh, I want
All
to
right.
find someone else.
Oh, okay. I don't think that's how that works. But all right. Thanks, Pamela.
Thank you, Fraser. And
And
now I stop the recording.
you're gonna stop the recording, and you're gonna record
I'm going to
something
record the
else.
names once I figure out where they are.
Okay.
So
Well,
for
that's a
those
time
of you who
saver.
are here watching right now, we are supported thanks to the wonderful generosity of all of our patrons on patreon.com/astronomycast. And Beth, who is on vacation and at Disneyland right now,
Wow.
put together a glorious document that has broken down all of your names so that
And then you lost it.
I didn't lose it. I didn't save the link for it. The document is still exactly wherever she put it. I just don't know where that is, which is different than losing it.
Right. All right. Let's tackle some questions. Okay. I'm uploading. Here we go. There you go. Raj Luther said, what about an electric solar wind sail or a magnetic sail? Exactly. I was talking about it. And I think someone else was talking about nuclear rocket. So McKinney asks, what is the, are you familiar with the Pioneer anomaly? If
Yeah.
so, what is the latest explanation?
So the
I'm
latest explanation I know of, and you may have followed this more closely than I have, is just combinations of outgassing and interactions that just weren't expected.
Nope,
No?
nope,
Okay.
nope.
Tell me, lay it on me.
Sure. So, of course, the Pioneer anomaly. This is uh, a a the Pioneer spacecraft has an acceleration away from the sun that is different than essentially Newtonian mechanics should have dynamics should have anticipated. And for the longest time, astronomers were trying to figure out what's going on, why is this happening, and they assumed that there was some kind of heat that was coming off of the spacecraft.
Yeah.
And so what they figured out is that there's like the RTG that's on Pioneer is shielded in a bunch of directions and it's kind of open on one side.
Oh,
And so what was happening was Pioneer was turning its main antenna back towards the Earth to communicate its data for long periods of time.
yeah.
And the RTG was giving off heat, giving off photons in that direction that was causing it to accelerate
That
in a
makes
funny
so
way.
much sense.
And because it was spending most of its time back towards the Earth, essentially back towards the sun, it was causing this uneven acceleration. Because otherwise, it would be like you wouldn't if it was just giving off heat in all directions, then you would expect it to not be showing up. But it was weird that it was showing up in one direction. It was because of the way the shielding was on the RTG, and so it's fully solved. Like they know with
Excellent.
absolute precision why this is happening. It is no longer a mystery. Um, Pod Lewis is quite disappointed they didn't mention teleportation. Just beam me up works for some people. Yeah,
I'm not into using a suicide machine today.
right.
Maybe tomorrow.
Maybe tomorrow. Um, let's see.
I am so amused by your floating body.
um, Raj Luther asks, when do you think we will see a laser solar sail used, and will it be better to attach the laser source to the sails?
Um, so if you attach it to the sails, that doesn't work
Right.
because the back end of the laser is pushing in one direction, and the laser is pushing against the sail in the other direction, and it just sits there going, "Hi."
Yeah.
It's like playing tug of war with yourself. It's no fun.
Right. Yeah. The laser, like the thing you don't realize, this is the same thing that's happening with Pioneer anomaly.
Mm-hmm.
The photons are causing a force as they leave the spaceship. Just
Mm-hmm.
heat is causing an acceleration of the spaceship. If you put a big powerful laser on your spacecraft and you fire it, then that's a propulsion.
Mm-hmm.
And if you then catch it with the solar sail, you're
You're
just
stopping
stopping yourself and
yourself.
yeah. Yeah.
So there's been some really cool ideas to like there was one to build these itty bitty little tiny things that they were going to send towards Alpha Centauri using lasers. But right now, we're kind of foiled by the fact that we don't really have the lasers you would want.
Yeah.
The lasers we use for things like laser ranging are laser beams shot at the moon that are kilometers wide by the time they get there.
Yeah.
And so you're not going to get that many photons hitting the sail. By the time that laser beam has gone from the Earth, reflected off of the reflector on the moon, which admittedly isn't that big, and then makes it back to the 30-inch telescope at the laser ranging station out at McDonald Observatory, they're catching like 6 photons.
Right. Yeah.
You need
So,
to do
so
better than 6.
So one of the ideas that we didn't talk about, but it is kind of theoretically possible, is in the far future, when we do have these lasers set up
Yeah.
across the solar system, you can imagine like your spacecraft goes in front of the Earth laser and then gets accelerated out. You have a cruise stage, and then as you near Pluto, the Pluto laser fires on you and decelerates you with the opposite amount of force that you got from the Earth laser. And but you can imagine like you're going to need like petawatt laser arrays set up across the solar system to accelerate and decelerate payloads going off to various destinations. But it's
and you
theoretically
can't put
possible.
these on the surfaces of worlds you like because they're going to give off so much heat.
Yeah.
So we can't put high demand supercomputing of the future, if humanity becomes a singularity, on the surface of our planet because of the heat issues. And we certainly can't put laser beams that are shooting things all over the solar system on the surface of the planet. So we need to figure out the energy generation, the stability, and putting it not on a planet.
Yeah, these would be in orbit. So Astro B London asks, what is the theoretical maximum speed of a chemical rocket? Theoretical.
I don't know.
It's the speed of light. It's essentially just shy of the speed of light.
Yeah,
You
just
just would
shy of,
require,
well,
but you would require more
so
mass of
than
propellant
exists in the universe.
than exists in the universe. Yeah.
So like the theoretical given like a solar system size of mass or something is, I don't know. I'd have to figure it out.
So the number that I heard was if you wanted to get to 10% the speed of light, you would need enough propellant in the observable universe. So if the observable universe was your fuel tank, you could get to 10% the speed of light with a chemical rocket.
Okay.
Which is ridiculous.
Yes.
So chemical rockets are not going to do the trick.
No.
The
ion drives.
Ion drives will get you faster, but you would still get to a point where you're gobbling up vast chunks of the universe. You need the propulsion system with the highest specific impulse, and that is photons.
Yeah.
And so the only, like maybe fusion drives, but really the only thing that gets you ludicrously fast is catching photons or emitting photons. So
yeah,
light sail or a photonic drive, but then you need the mass of the universe in solar sails or RTGs or whatever, right?
Yeah.
But it's pretty ridiculous.
Reality is the constraint, not the engine.
Yeah, really sucks.
Yeah.
Finn Jocks asks, why does everyone dismiss the litho breaking?
Well, I mean, you're welcome to try. I'm just not sure it's the best thing you should do to your optical system.
Yeah. Yeah. You just like, yeah, you smash into the moon, say, at, I don't know, 8 kilometers a second.
Well, Mars Polar Lander is a perfect example of lithobreaking. It very successfully lithobraked.
Yep.
And was not useful on the other side.
Right. Yeah. Because again, you're sort of smeared out into they're like a little bomb going off, hitting the surface of Mars. You make a nice little mushroom cloud, and then and then a crater, and you disappear. So,
we have an air compressor in the background.
Oh, good. How many can you saying? I thought the Pioneer anomaly was an unexpected perceived slowing. Yeah, like I said, it's an acceleration. It's an acceleration in the direction away from the. It's an acceleration to slow it down, but it's still an acceleration. So a deceleration. So apologies if I hadn't made that clear. Raj Luthra, any news on a possible warp drive?
No.
Astro B, what is the fuel source of ion drives and nuclear rockets?
Nuclear rockets, they're using plutonium, I think.
Mm-hmm. Yeah, and then they're using like hydrogen gas as the actual propellant.
Yeah, and with ion drives,
electricity and xenon.
Yeah, it's ionized xenon, and I don't remember what their electrical source is.
Oh, like solar panels.
Oh, yeah, that I'm just.
Slam RN, can you talk about the problem with cosmic ray damage and what it would take to protect humans flying outside our magnetosphere? So we just reported this on Universe Today, the coolest story. So I just want to nerd out about this for a little while. So there was an experiment that just flew on the International Space Station where they grew fungi on the space station. And the fungi is the stuff that was found near Chernobyl. And it was found to essentially be living off and absorbing the radiation from the Chernobyl reactor. And what they found was that this stuff absorbs radiation and grows from it. And so what they did this experiment. They had this like thin little layer, it was like 1.5 millimeters thick of fungi. And then underneath, they were testing the amount of radiation that was getting through the fungi from space. And they found it had dropped by 2%.
Dang.
And so this radiation loving fungi, but imagine like meters thick, but this stuff is growing while it's sitting in space.
We're going to travel through space inside of an asteroid or inside of a giant mushroom ball.
Exactly. Covered, surrounded by mushrooms that are growing off of our poop and protecting us better and better from space. But if you don't have radiation absorbing fungi, then so read that story on Universe Today. It's like one of the newest ones on Universe Today. And
I've been working on grants, so I'm behind on some of this.
Yeah. And the but then otherwise 1 meter of water or 3 meters of rock will protect you from radiation in space.
I will eternally be a fan of finding an asteroid that isn't Bennu or Ryugu because they're rebel. They don't count. Finding an actually solid asteroid and hollowing that sucker out.
Good luck.
I know.
I now seeing Ryugu and seeing Bennu, it feels to me like they're all rubble piles, except for the metal ones.
We're gonna find out, aren't we?
Yeah. I mean, obviously the big ones, Ceres, Vesta. Like once you've got enough mass to hit hydrostatic equilibrium, then that's a different story. But
yeah, but they're a bit too large to easily like transfer orbits with.
Yeah, exactly. Yeah, you're not going to hollow out Ceres,
right,
and fly from world to world. So it does feel like
Itokawa looked fairly solid-ish. Ish.
How big? I don't know how big Itokawa was compared to
Itokawa
Ryugu.
was another sub-kilometer one.
Yeah,
it was similar in size to Ryugu and Bennu, just more cashew shaped.
Yeah. Astro B, at any appreciable fraction of the speed of light, how would you detect and avoid space objects?
You don't.
You don't. Yeah. So again, I did a story on this. A piece of sand hitting your spacecraft is doing 100 tons of TNT if you're like 10% the speed of light.
Yeah.
So
that's a no.
That's and you're going to be hitting lots of it.
Yeah.
In fact, the did you see this story about the Parker Solar Probe and the problems they're having with space dust at the high speeds that it's going?
No.
Yeah, so Parker, of course, as we mentioned earlier, the fastest spacecraft ever sent by human beings, is doing these incredibly high speed flybys of the sun. And it's getting so fast that space dust is smashing into the spacecraft at pretty high speeds and starting to cause problems with the spacecraft. And so they're having to sort of figure out workarounds. But it's like it's not like it's carving out chunks of spacecraft, but more like, I forget what it is. It's like creating electrical disturbances as it's interacting with the spacecraft at these high speeds. So yeah,
it's a hot mess.
Yeah, so there is no way to stop your spacecraft from being pulverized as you approach light speed.
Shockwave. You have to have a bow shock. Is that the correct side of the spacecraft?
Yeah. Well, the idea that I've heard is a multi-meter thick block of ice.
Well, yeah, there's that too, but
and then
I still like the idea of
like a
shaped shockwave that tunnels you through space.
What kind of science fiction problem is that?
one I don't want to run the calculations for.
Yeah, where does that come from? How do you releasing gravitational waves? What,
I don't
what,
know.
what wizardry is this? Um, Hal McKinney asks, are spacecraft speeds derived purely on how redshifted these radio signals are?
So spacecraft speeds are pick a frame of reference and and measure your speed relative to that frame of reference. So within our solar system, we usually measure speeds initially relative to the planet Earth, and then once you're beyond the planet Earth's influence, it's more relative to the sun. Um, Redshifts are part of how we get at that information, but that only tells us the speed of something in the direction towards and away from us. So
Right.
something can be moving very fast perpendicular to our line of sight, and we can't measure that part of the velocity with redshift. So this is where you have the tracking it across the sky and measuring its redshift, blue shift perpendicular to the sky.
Right, right. There have been a few alternative ideas that have been developed. One is stellar navigation, so the Deep Space One mission, which was actually the first test um, of an ion engine in space. This is like 15 years ago or so.
Mm-hmm.
It had an ion engine, it had a whole bunch of technologies, and one was it had its own celestial navigation system on board, so it could figure out where it was by looking at the planets and then looking at the star fields around it. So it
Are
knew
you
where.
watching Foundation?
Yep. Yeah.
I loved this. I don't think this counts as a spoiler. There is a scene where a character doesn't have access to the computer's
Mm,
detailed information, and the character is able to figure out what is being looked at by performing celestial
yeah.
calculations.
Yeah.
Trig,
Yeah.
basically. And it's
Yeah.
just this amazing set of scenes to watch.
But she's very good at math.
Yes.
Um, the
And not
other
have a
system
spoiler.
is
I was more careful.
pulsar navigation.
Yes, that's super
So
cool.
yeah, and so this has actually been tested in space as well. And essentially, you have a spacecraft get a fix on a couple of pulsars, and from measuring those pulsars, they can, measuring the redshift to those pulsars, they can actually figure out where they are with high precision to pretty much anywhere in the solar system.
And then
So
for
we're
intergalactic, you just use quasars.
right. Yeah. And then you could still probably use pulsars if you need it. But just the fact that even in the solar system, you observe three pulsars and it's GPS system, you know
Yeah,
exactly where you are because you know what the redshift of those pulsars should be.
yeah,
And your spacecraft adds velocity to that redshift or takes it away,
yeah.
which is so cool. Okay. I think we've reached the end of our time, so we
We
should wrap
have.
things up.
All right.
Um yeah. So what are you working on? What should people pay attention to?
Um, my grants all go in Monday, so I get my life
Oh,
back.
a
Sunday I'm gonna
lot of
be
people are writing. Are everyone's grants sort of arriving at the
everything
same
is due
time?
Monday.
Yes.
November
Okay.
15th is the big deadline for the year when all NSF astrophysics grants are due on one day.
Yep.
So collectively, the astronomical community is all going a bit crazy right now.
Yeah.
But I have all the parts I need to have done. I just need to go make sure that no one needs me to proofread anything. So Sunday, I'm going to spend the afternoon actually working on some artwork, and I'm super pleased that one of my pieces of art that was actually multimedia, I combined an actual painting with a digitally rendered pair of stars, was picked up and used for a press release by the
I
SETI
noticed.
Institute and by the Planetary Science Institute. So it's just like my art is being acknowledged.
That's so funny.
So it's super cool to get to have this hobby I picked up on, get to see it applied. It's
Yeah.
just
Yeah.
cool.
Yeah, it was funny. I looked at the press release and then it had like PSI, like the art credit was PSI Pamela Gay. I'm like, right on. And then I
Yeah.
realized like that's that's a painting of a planet. And so,
Yes.
yeah, that was so great. And so I normally don't kind of go into that little detail, but when I did the tweet mentioning it, I included your name in the tweet because it was so cool to see it. So congratulations. That's
Thank
awesome.
you.
Yeah,
I'm
that's
super
fantastic.
pleased.
Yeah. Okay. All right. Well, thank you, everyone, for joining us today. Thanks to all the mods and all the people hanging out both on YouTube and Twitter. Oh, sorry, YouTube and
Twitch.
Twitch. We appreciate you watching us, and we will see all of you next week. Thanks, everyone.